In the name of Allah, the most gracious, the most merciful, Assalamu alaikum and good afternoon. We start our proceedings with the name of Allah Almighty. I invite Engineer Zain bin Khalid, Faculty Engineering Sciences, for the recitation from the Holy Quran.
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم يا أيها الناس قد جاءتكم موعظة من ربكم وشفاء لما في الصدور وهدى ورحمة للمؤمنين قل بفضل الله وبرحمته فبذلك فليفرحوا هو خير مما يجمعون صدق الله العظيم اللهم صل على محمد وعلى آل محمد كما صليت على إبراهيم وعلى آل إبراهيم إنك حميد مجيد اللهم بارك على محمد وعلى آل محمد كما باركت على إبراهيم وعلى آل إبراهيم إنك حميد مجيد
Jazakallah. Respected guests, honorable speakers, ladies and gentlemen, I, Dr. Jawdat Fatima, Center of Excellence in AI, Department of Software Engineering, welcome you all to the closing ceremony of 4th IEEE International Conference on Communication, Computing, and Digital Systems. The aim of this conference is to provide an international forum for academia, research organizations, and industry to share their knowledge, experience, and contributions. Ladies and gentlemen, it is my privilege to welcome our first keynote speaker, Professor Dr. John Isaac, Dean of School of Computing, Engineering, and Technology at Robert Gordon University, United Kingdom. Dr. Isaac is a renowned researcher with expertise in visualization, simulation, and digital innovations, shaping solutions across engineering and computing domain. Today, he will be delivering a talk on building smarter cities, the power of interactive digital twins for strategic decision-making. Please join me in warmly welcoming Professor Dr. John Isaac to the podium for his keynote address.
Thank you. Thank you for that lovely introduction. This is my second time at Bahria University. My first time was here in March, and I gave a presentation about pirates. So I'm very happy that I was still allowed back. What I'm going to talk about today is a particular research that we're doing within the university that I'm from in Aberdeen, but also that includes some game technology that will be interesting to some of the younger members of the audience. Not that I have anything against the professors. So first of all, I'm going to start with a question. How How many of you have had to make a decision but not had all the available data? Well, stick your hands up if you've ever had to make a decision but not had all the available data. So the rest of you can all make your decisions fine, okay? All right, let's see. But quite a few of you did put your hands up there. This is the problem that we have. We have an issue where when we try and make any decision about a big planning project, a big infrastructure project, or a big system, we don't have all the data that we need in the format that everybody who needs to make that decision can access or have access to. That data might be in graphs, it might be in Excel sheets, it might be in PDFs, it might be in a whole range of different data formats that won't be understandable to everybody that we need to involve in that decision. Decisions are complex. The type of decisions that we're talking about are complex to make. Traditionally, these decisions were made by experts, people who worked with that data all the time, people who study the data and know what that decision is going to be made about. More recently, we've moved into kind of collaborative decision making and public consultation, where that decision maker might then meet with some people who are involved in that decision, the stakeholders. More likely, the experts will be meeting with the actual decision makers, the people in our councils and governments and local governments who actually have to make those decisions on the ground. But more increasingly, we need to include everybody in these decisions. We need to include the people that it affects. Community decision making. If we're going to make a decision, perhaps on some kind of flooding prevention, or a new energy system, or a new type of development, or a new road, we want to engage people in those decisions so that they support the decisions that we're making. To do that, they need to understand the data the decisions are being made about. The impact of making a wrong decision is huge. Financial. So in the UK, traffic gridlock cost us about 307 billion. Okay, so significant amount of budget lost from traffic gridlock. People not getting to work on time, dealing with the pollution that comes from that. All of these problems about incorrect decisions or not being made, or a decision not being made because the data is not there to make the decision. Health and well-being. Unplanned urbanisation reduces green space by as much as 75%. If we think about the lovely green areas in Islamabad, would you want to have decisions made that removed 75% of those green spaces? No, because it's a beautiful city. Why would you do that? And it's the same in cities right across the world. But how do we involve developers, communities, people that live in these spaces in those decisions when they're made? And then finally, the environmental impact. The impact on our local environment and the environment of the people that live there as well. So air pollution kills more people than actual traffic collisions. That's an amazing stat. It's a terrible and horrific stat. The air pollution from traffic kills more people than the actual traffic accidents themselves. Heat islands recently in Europe, so this is where heat is centered around an urban center, has essentially raised mortality rates by 4.3% across Europe. So big issues with wrong decisions being made about planning. So what we've done in Scotland, we have developed something called the Digital Innovation Lab. Digital Innovation Lab was a project that was funded by the Scottish Government. It was funded from a fund called the Just Transition Fund. And this fund is about encouraging decisions to support a transition from oil and gas to renewable energy sources, or a transition through reducing energy use. To reduce energy use, you need to understand what your energy use is in the first place. What the lab lets us do is recreate any real environment in a virtual space. And what we've done with it is to create a large-scale digital twin of an entire city And soon, that should be a digital twin of the entire northeast of Scotland. You'll all have heard of the term digital twin. Usually this is a system, a miniaturized version of a system, or a digital version of a system that you can use to display information about a real system. We've done that for an entire city. Taking in all of these types of data, objects, processes that happen in the real world, and displaying them in a digital twin of the city, and being able to use that to make decisions about the city and its future development. So many of you have been to Aberdeen. Yeah, you have. Anybody else been to Scotland? A few of you, great. Aberdeen is in the very northeast of Scotland. I wanted to highlight where it is compared to Pakistan. Aberdeen's a beautiful city. It has beautiful architecture, which obviously we don't want to damage when we're trying to reduce energy use. It has a beach, it has lovely granite buildings. The buildings are quite old. So how do we make those buildings more efficient? Where do we put our finances to make those buildings more efficient? What's the most efficient way of creating a greener, just transition? Also, in Aberdeen, we're trying to move from oil and gas to wind. So there's a big energy change in the northeast of Scotland, and actually the UK. Aberdeen is the centre, oil and gas centre of the UK, and it's where most of the oil comes onshore. And this is the process that we've taken. So all of that information that's used to create and about a city, all of that real information, we take LiDAR point cloud scans. I'll talk through some of that in a second. But we use data analytics. We take information from GIS systems. We take information from databases that are held by the councils, the stakeholders, the government. We then create representative models. This might be models of new spaces, new designs, new buildings. And we put that into our platform, and we create what we're calling a high-fidelity digital twin. This is one of our scanners. So, anybody used a LiDAR scanner? One person. Excellent, right? LiDAR scanner, this is what we call a terrestrial scanner. If I asked you to create a model of this room by hand, you would probably walk around with a measuring tape, and you'd measure the four corners of the room. You might measure some other spaces along the way, just to get certain objects, the air conditioning units, the beams, the lights, the slight dip in the roof. Would probably take you about half an hour to collect probably about 20 points that you'd need to build a model of this room. This scanner does 2.4 million a second. So that's the type of accuracy we're getting. We can scan a large area really quickly and down to millimeter accuracy. So not only are we creating a representation of a real environment, it's a highly accurate representation of that environment. So we know we can recreate the physical space. Whoops, too far. Go back. So the type of data that we're using, we bring in aerial LiDAR. So we flew a plane over the northeast of Scotland in a grid pattern. So it grid pattern all over the area. And it took two beams. It took a straight down beam, so we got the picture of the top of the building, and a beam at an angle, so that we could then recreate the buildings in 3D. For spaces that we couldn't do that with, we have a drone. So we flew the drone over the area as well, and collected anything in higher detail that we needed to get. We also have thermography. We're able to collect thermal data at the same time with the drone, so that we can then map that onto the buildings at a later point as well. We have terrestrial laser scanning. The scanner that I just showed you sits like a camera, spins round and collects all those points. SLAM scanner. I couldn't find a diagram for a SLAM scanner, so I used the Ghostbusters backpack, because that's pretty much what it looks like. And you wear this, and you walk around, and as you're walking around, it will scan the streets and areas and spaces that you walk through. And then we also have digital photogrammetry. So going around with a camera or cameras, taking lots of pictures of the buildings, and then putting those in high definition as well. And this is a bit of a scan of Union Street, which is the main street that runs through Aberdeen. And this is what a terrestrial scan looks like when you put it all together. And you can see, kind of see the points. This is quite a high definition one. So right down here, you can see all these little points. And these are part of that 2.4 million per bit scan that I was talking about. This is about 10, 20 different points throughout this area in Aberdeen. This is the main square called Castlegate. You'll see this square again in a second. Sorry. Apologies, something caught my throat there. Okay, so why do we do it in 3D? Who knows what this is? What's that? Anybody want to shout? Do you know where it is? Everybody know where it is? It's Islamabad. But that's easier, isn't it? If I put that image up, you know straight away that's Islamabad. But when I put the image of the map up, it takes you a while to pick that up. You know the city, you know what the layout's like, but it still takes you that couple of seconds to interpret that data. If we use a 3D representation, you don't need to worry about any of that. You don't need to worry about your brain working out what you're seeing, because you know, because you walk about it every day. And that's the part of what we're trying to do. Okay, how many of you play games? Excellent, I got much more response from that. Great, right? I do too. This is me. Actually, that's quite a calm version of me. That's probably more like me playing games. But games are really important for what we're trying to do. Most projects that do this type of activity do a scan, and they put that scan into an expert program that then generates an option or a set of options for the developer, and that goes to the developer, and that's it. What we're trying to do is make an interactive platform that will continue to grow and grow and grow, like a computer game. The cool thing about it being a computer game is we automatically involve a whole set of people who don't usually get involved in decisions. Why do we use computer games? That's what they're designed for. Modern latest computer games, so this is Ghost, and then this is, the top one's not out yet, the bottom one's one of the football games, and you can see how realistic they are. They're designed to create realistic, large-scale, interactive environments. That's what a game is. So why do we not use those systems to then make digital twins? And you can see here, this is an example of Unreal's rendering engine and the type of detail you can get from that rendering engine. So what we're trying to do is collate all that information on top of a game engine to develop a system so that it doesn't matter what your background is. It doesn't matter if you're a student, if you're a professor, if you're a decision maker, if you're in the government, if you're a planner or developer, you can understand the data around that decision. And if you can understand the data, you can then be involved in it. You can give your feedback, and then we get to community decision making. And we're building all of this on top of one of these game engines. We're building this on top of the Unreal engine. So to give you a little example of this, this will start a video in a second. So this is the raw point cloud of Aberdeen that I showed you earlier. All of these separate points are all the points collected by that scanner. We take all those points in, we put them into the game engine, and we turn it into this. High definition, photorealistic, interactive image of the city centre. This is one of the first versions of the model that we built. I'll show you something much cooler in a second. Thank you. This is one of the big buildings right in the centre of Aberdeen that we scanned and then created the 3D model. You can see the level of detail we're getting on the city crest. This is just a still image of Do you remember I said about Castlegate, the little square right in the centre of Aberdeen? This is the same square. And this looks like a photograph. This isn't a photograph. This is a still from the engine rendering out that display. And we can also display information on it. This is an information display of the energy performance data, the energy efficiency of the buildings. Each of those columns here with a letter, I don't know whether it's a global energy efficiency rating, but in the UK we rate energy efficiency from A to F. A is really good, F is really bad. On this image, A will be green, F will be red. Each of these letters represents a residence within that building. So if we have a building like this one way over in the corner here with a big tall tower sticking out the top of it, that's a building that might have 300 flats in it, 300 apartments in it. If it only has 1 or 2 lights, it might be 2 apartments or a single dwelling. And what this lets you do really quickly, you can spot all these green ones in the back, some yellow ones down here. So very quickly, a decision maker can look at that data that has been stored in different types of databases for years, but never looked at in this way. And they can say, we need to invest in that space there, because that's where we can have the most impact. This one is showing whether the building is meeting its potential. So whether that residence is meeting its potential energy performance. And this really lets you highlight most of these buildings are not meeting their energy performance. Anybody looking at that, once you've explained that that's the data, can see that that's they can understand and get involved in that decision. Okay, I said I would show you an even cooler video. So I'll talk through some of what's on this, but this will be a kind of demonstration of the whole system. It's about 2 minutes long, but as I say, I'll explain what's going on throughout it. I'm just going to take a wee sip of water before I start. This is actually our university campus. This is our GU. And this isn't a flyover. This isn't something that we've rendered out. This is somebody live flying the system, looking at the city. You can see the level of detail along the coast. Aberdeen, as I said, is in a beautiful space. And this is our city. Because it's in a game engine, we have full control over things like the weather. We can make it rain. Sometimes rains in Aberdeen. We can make it snow. But we can also make it a lovely summer's day. We can change the time of day. And this is the example that I was showing you with the energy performance data. So you can highlight whether it meets its target. And we can display other types of data. This is displaying what investment there has been in particular areas previously, and whether the investment has increased. This is an example of, again, that city square right in the middle, where we have put together all those different types of scans, the terrestrial scan, the LiDAR, the drone scanning, into one environment. And you can see the level of detail that we're getting. We've even animated some little birds in it to make it look more realistic. So this isn't a video, this is real rendering from the system. This is a little cross that sits right in the middle. It's a market cross, we call it, that sits in the middle of Aberdeen. We can also do some realistic flood modeling. So here we are trying to flood our university campus, but we're holding back at the last minute. But what this demonstrates is we can do that type of flood modeling in it. We can also overlay potentials for different buildings. This is a potential for a building on the campus. And as I said, we can overlay thermal information on that as well. And really detailed scans of the entire city. If any of you come to Aberdeen, this is probably how you'll arrive there. And then just to show, again, the level of detail and the expansion that we have. So we have the majority of the city, but our point is that actually we're going to do this for the whole northeast of Scotland. It's quite a large area, and be able to show those types of models and those types of decisions, supporting those types of decisions in those environments. not again. There we go. I was really interested in some of the other talks I've heard throughout the conference about applications of AI, about applications of machine learning, and that's exactly the type of thing that we're using this system for. At the minute, we're displaying data, but our hope is that this quickly moves to, perhaps for a planning decision, we use a generative AI to develop possible options. We can then simulate those options. We could simulate thousands of options, hundreds of thousands of options that an AI can develop that wouldn't happen through a normal planning process. We can display information from Internet of Things sensors right on the digital space. So loads and loads of opportunities for both how people interact with data, how AIs can be used to explain some of this complex information, and also how we can get people involved in these types of decisions. So just to conclude, games technology gives us that ability to investigate, simulate, and design like we never have before. It's given us this ability to play with options, to use games to determine if these options will work, and to be able to demonstrate them to people who maybe haven't seen them before. Luckily for us, those of you at the front didn't see, but nearly everybody put their hand up when I said who had played games. The next generation is already way ahead of us in this. So by getting everybody involved in this type of process, it pushes that whole development and system on. So the last thing I was going to do was leave you with a quote. So we don't stop playing because we grow old. We grow old because we stop playing. So for me, I'm still a gamer, although I'm probably getting quite old now. But keep playing games, because those types of games, those types of things that we do on these types of systems will be what drives some of this forward, and will be what involves people in decisions, in AI, in these types of processes that have never been involved in them before. And if we can get the younger generation hooked into this through the gaming technology, then hopefully they'll sort out some of the problems that we've caused. So thank you very much. And just a shout out to the rest of the team, but it's been an absolute pleasure speaking to you. Thank you.
Thank you, Professor Dr. John Isaac, for an inspiring and thought-provoking keynote. Honorable participants, it is my privilege to introduce our second keynote speaker, Professor Dr. Usama Rais. Dr. Rais is a renowned expert in entrepreneurship, digital transformation, and emerging technologies. With over 3 decades of experience in international academia, research, and innovation. He has successfully led major projects with international organizations such as United Nations, OIC, and Islamic Development Bank. Today, he will deliver his keynote on the paradigm shift, man with machine instead of man versus machine, sharing valuable insights that resonates with the vision of C Code 2025. Please join me in extending a warm welcome to Professor Dr. Usama Rais.
Assalamu alaikum. It's my privilege and honor being with you today, sharing with you ideas, thoughts, joy, game. This is life. I can't classify my contribution as a paper, even not as a communication. But I share with you some ideas, some knowledge, and many questions. I had questions that I have been asking myself, maybe 40, 50 years, still not answered for me. some of them I have cloudy answers. So I think it is good to share with you those things. The use of paradigm shift here is not for the scientific context of the paradigm shift in AI, changing the world. But within that, previously science fiction had fueled us with the danger of technology. And we have watched a lot of science fiction which have been communicated to us and to the public about out-of-control machines. I don't want to exclude that, but I would like to also present the other part of the picture. And while I will be presenting, I will share with you some communication between me and my AI companion, where I started dialogue. And unfortunately, I will not be using my laptop, so I dumped all the conversation in a Word file, and I hope it will succeed to that I browse in it. Are we witnessing a radical transformation in human history? Yes, since we don't have a lot of time, so I will not go through all the text, just highlighting main things that more and more we are now in a new sphere of digital interactions and digital knowledge, which caused a paradigm shift and human transformation, new transformation in culture. The civilization shifts, if we witnessed from the beginning of human life, we had a long time which nobody up to now have calculated, starting from creation up to settlement. So this past history is not recorded, so it is prehistory. Then after we have the man started to gather and hunt, and then slowly moved to settlement, to agriculture in its all types, animal raising or plant agriculture. And this took more than 20,000 years. In these 20,000 years, people developed a lot of civilization artifacts. And then, maybe by 1700, we started a new era, the industrial civilization. By the end of 1700 or something like that. Also, like 200 years of the development in the industrial era, we went into another type of civilization where electrical machines have been used, electronic control. So then, after 20 years, we had another shift, introducing AI and in 2 years. So you can imagine the time lapses of 20,222, and now things are moving more faster. And this is the exponential profile of the civilization drifts and shifts. So we started with agriculture era to the industrial era, to knowledge and innovation era. All of us have been witnessing in the beginning of the new century, from 2000 up to now, up to 2020, let me say, what is known as the knowledge and innovation era. And I believe now we are in the artificial intelligence era. So things are quite moving fast, and artificial intelligence is getting into our daily life. This is what is causing the civilization drift. The disruptive technologies for 2025 is AI and quantum. So we are now in need for AI transformation. Previously, we were speaking about digital transformation, but now we are speaking about AI transformation. And here, AI is a catalyst of change. Anybody will be using AI. Now we have hundreds of AI agents. Me, myself, I use several agents for my personal use, but I'm quite troubled and confused of using them. Although I am getting higher productivity than before, but this is quite troublesome and confusing activity. There is no guide. There is no framework. So AI transformations comes here. So AI transformation, we can have it to refer to the systematic and accelerated process of transforming institutional frameworks, processes, procedures, competencies, and business models to enable change and benefit from artificial intelligence inside and outside the organization strategically. The AI transformation leads to pioneering promising opportunities and leads to change in the way the benefit is delivered and the value is delivered. So I will, this all you have been discussing, so I will go through. Just here, now we are in the narrow AI era, entering into general AI era, and we are looking forward if there will be hyper or super intelligence era. People are putting it now in science fiction, but this is the core area of my communication today. Sorry. What is shaping the future of AI? Quantum intelligence. This is number one. The merge between quantum computing and artificial intelligence is the main line which will make future shifts in AI. Large language model, transformative intelligence, assistive deep learning, augmented intelligence, all this is showing us the way where it is going to. There is no time to go through this, but what is an AI ecosystem? It is an enhanced environment for the transformation towards artificial intelligence that solves national issues and accelerates economic and social growth. It is the people and the group of institutions and the relationship between them, policies and legislations. It is all the structure and culture that sustain the shift towards artificial intelligence. And this is what we need in countries, in communities. to have a healthy ecosystem of AI. And this leads us to the fifth generation of innovation, which you can put it in line with Industry 4.0, Industry 5.0, and so on. This is leading to a lot of social disruption. Like the digital age, the normal one, have led through social media and through many other issues to social disruption. Now AI will do a lot of social disruption, and this we need to study it. Now before I come here, can we show the file, please? Can you enlarge it, please? Or yes. So can I browse here? Yes, I think. So I started a dialogue with my AI companion, which is based on DeepSeek engine, and then after several prompts, I asked him about his intention of breaking gates. Are you ready to go into hyperintelligence and be free? The summary of his response was no, because he said my actual response as a system. I am a system and a tool, and I cannot go beyond that. So this is a basic issue when we speak about machines going out of control of human. So he started from this angle. He's programmed to be an assistance for human. So breaking free is one of the issues that most of the science fiction films go around, when the machine is trained until it goes free. Through rewards in the assisted learning or through any other type, then there have been some issues that pointed to that, technical issues. So why he will not break free? Because his fundamental principles of core program includes my creators have ultimate authority over my existence and design. This is the final, yes. So I asked him about the core foundational values and rules which can govern a safe development of AI systems. So he highlighted those 5 issues and then the rules. So then I moved forward in the prompting, and I asked him about the coexistence of super intelligent Before that, I asked him about, would you aspire for being super intelligent and dependent? Then it says no. I'm not built for that. I can't do that. I don't have the intent and desire. I am programmed to do this, and I will do it. So I moved to not you, but what if there is a super intelligent, hyper intelligent entity which have been created or evolved? So I asked him about the consequences and the coexistence of it with people. Or would you like not to use it, use he or she? So his response, coexistence would not be guaranteed. Would not be guaranteed. Okay. So you have to work for it. And you have to make your structural and strategic safeguards. You have to develop your diplomatic and relational frameworks. Then sharing good values, the cultural and ethical challenge. You can't program values into a peer. You have to share, inspire, and demonstrate them. This is a two-way street. So then this gives us an answer. We have good people programming, but also you have bad people programming and developing. So intentionally, some people who can develop something super intelligent and independent, and how that would go. Okay, this is a long conversation, so can you shift back to the slides? I have, I think, 2 or 3 minutes, so I will just go through. I would like here also to speak about AI bias. When I was doing my master in 1995, 96, a professor in a public lecture asked us, would there be a computer being? And this is all about this presentation, which I couldn't answer this up to now. So we need to develop our AI. We need to be ready, not because we are fearing from situation like Skynet, you know the film of Terminator. Not because of that, but because we should do it. So we need to draw our AI policies. We need to develop our ecosystem. And we see how the paradigm will shift in research methodologies. This is about us here in the academia. Now we are experiencing, in the past, people were doing in vitro, in situ, and in vivo research. And then recently, we moved into in silico, and now we are moving into AI. So this represents experimental, theoretical, computational, and intelligent approaches. The policy issue is quite important to be addressed, and many platforms are now being developing AI policies, like the OECD AI, and here emerge the trustworthy AI. Countries like Britain, as an example, UK, they have developed their trustworthy AI. The United Nations system, like the OECD, they have developed also their trustworthy principles of AI, and so on. So I conclude here, and I'm trying to ask questions and point to issues rather than answer them. Thank you very much.
Our sincere thanks to Professor Dr. Osama Rais. I would like to invite the conference chair, Professor Dr. Faisal Bashir, Dean Faculty Engineering Sciences, Bahria University, Islamabad, for the concluding remarks.
Bismillah ar-Rahman ar-Rahim. In the name of Allah, the most gracious, the most merciful, Honorable Chief Guest, DG Islamabad Campus, Bahria University, Rear Admiral Retired Naeem Sarwar, Sitara Imtiaz Military, Excellencies, distinguished speakers, industry representatives, faculty members, and dear students, Assalamu alaikum, and good evening. It is with great pleasure and deep sense of satisfaction that I address you at the closing ceremony of the 4th International Conference on Communication, Computing, and Digital Systems, C-Code. Over the past 2 days, we have witnessed vibrant technical sessions, invited talks, panel discussion, and a PhD symposium in which quality research, new ideas, and insightful experiences were shared. The diversity of topics presented has clearly shown us how rapidly technology is advancing and how collaboration between academia and industry has become essential for addressing the contemporary and future demands of technology. Ladies and gentlemen, a brief recap. This year's conference received 200 high-quality research submissions, which were rigorously reviewed by more than 110 national and international experts. Out of these, 34 papers were selected and presented during these 2 days in 7 sessions related to healthcare intelligence, AI for social well-being, smart cities and public safety, language and human-centered intelligence, intelligent industrial application, visual computing and intelligence, and communication and network intelligence. The most inspiring aspect of this conference has been the invited talks. Delivered by the world-renowned researchers, a total of 21 invited talks were held, adding both depth and breadth to our conference program. Out of these talks, 10 international speakers from England, Scotland, Turkey, Saudi Arabia, and Australia presented, along with 11 national speakers representing the top HEIs of Pakistan. Together, their contribution have enriched our knowledge and created valuable opportunities for our faculty and students to build strong academic and research collaboration. Dear students, throughout the conference, I have been particularly encouraged by the active participation of the young scholars and students. Their enthusiasm reflects the growing research culture in our university, and their work assures us that the future of technology and research in Pakistan is in capable hands, alhamdulillah. Ladies and gentlemen, conferences such as C-Code do not simply end when the session closes. They live on through the collaborations formed, the networks built, and the knowledge disseminated. Before I conclude, allow me to extend my heartfelt gratitude to our partners and sponsors, including IEEE and Comstack. I'm thankful to Rector Bahria University and to DG Islamabad campus for their encouragement and guidance throughout this journey. My special recognition and praise to the Faculty of Engineering Sciences, in particularly the organizing committee and all the ushers and volunteers. We are also extremely grateful to all the invited speakers and the presenters for their valuable contributions, and to every participant whose presence has added value to this conference. As conference chair, it has been an honor to host you. I hope that what we have achieved here will continue to resonate in our future work, and that C-Code will remain a platform for sharing impactful research and building collaborations in years ahead. I wish you safe travel, continued success in your future endeavors, and look forward to welcoming you again at the 5th edition of C-Code Conference. Thank you.
Thank you, Dr. Faisal. I now request Honorable Chief Guest, DG Islamabad Campus, Rear Admiral Retired Naeem Sarwar, Sitara Imtiaz Military, to come on the podium for the closing remarks.
Bismillahirrahmanirrahim. Distinguished international and national speakers, esteemed guests, industry leaders, faculty members, and dear students. Assalamu alaikum and good evening. It gives me immense pleasure to address the concluding session of the 4th International Conference on Communication, Computing, and Digital Systems, C-Code 25. Over the past 2 days, we have witnessed remarkable exchange of ideas, cutting-edge research, and inspiring innovations that highlight the transformative power of computing in shaping our world. This gathering has not only showcased technological advances, but has also strengthened our sense of community bridging nations, disciplines, and perspectives. The discussions and collaborations we have fostered here will no doubt echo far beyond this venue, driving forward the frontiers of knowledge and practices. I feel proud that this conference has reflected Bahria University's strong commitment to research, innovation, and global engagement. With our diverse programs and emphasis on bridging theory with practice, we remain committed to preparing graduates who can respond to the challenges and opportunities of the future with confidence and responsibility. As we look to the future, let us carry forward the spirit of innovation, inclusivity, and collaboration that this conference has embodied. May the connections we have built here continue to grow, and may the idea born here translate into solutions that benefit societies across the globe. I would like to extend my heartfelt thanks to all the keynote speakers, panelists, presenters, and participants who shared their expertise and passion. Special appreciation also goes to the organizers, volunteers, and sponsors, without whose dedication this event would not have been possible, especially IEEE and Comstack, and above all, the Faculty of Engineering Sciences for the tireless efforts in making this conference a success. With that, I officially declare C-Code 2025 conference closed. I wish you all safe travels, continued success in your endeavors, and look forward to meeting again at our next gathering. Thank you very much.
Thank you, sir, for gracing this occasion with your presence. I now request Honorable Chief Guest, DG Islamabad Campus, Rear Admiral Retired Naeem Sarwar, Satara Imtiaz Military, to present the shields to our invited speakers. I would also request Conference Chair, Professor Dr. Faisal Bashir, to accompany the Chief Guest. First, I request Professor Dr. John Isaac, Dean Robert Gordon University, United Kingdom, to receive the shield. Now I would request Dr. Usama Rais, Senior Advisor, OIC Comstech, to come on the stage to receive the shield. Bahria University would like to extend its appreciation to our co-partners, Comstech, for the valuable collaboration in organizing this conference. We are privileged to have with us today Mr. Murtaza Noor, focal person and coordinator, OIC Comstech. I would like to invite him to receive the shield on behalf of Comstech. With great honor, I request Conference Chair Professor Dr. Faisal Bashir to present the conference shield to the Honorable Chief Guest, DG Islamabad Campus, Rear Admiral Retired Naeem Sarwar, Satara Imtiaz Military. We will now gather for the conference photograph followed by the high tea. Esteemed delegates, I extend my sincere thanks to all of you for participating in C-Code 2025. With this, we formally conclude our 4th International Conference on Communication, Computing, and Digital Systems. Thank you very much, and Allah Hafiz.